Alright, video lecture 2.3. This is where our chapter really takes a turn in a new direction for most of you. We're going to deal with something called significant figures, and so if you have the question like this young student in the corner here, what are significant digits or significant figures? We need to have a definition here, and the definition you see here is the significant digits in a measurement consist of all the digits known with certainty plus one final digit which is uncertain and has been estimated. That's basically the same idea of our definition we'll have in our notes. All digits with known certainty plus one estimated digit. What we're saying is, if you would step on a scale and it would say 155.4 pounds, which of those numbers do you know with absolute certainty? And I think it should be obvious the 1 and the 5 and the 5 you all know with absolute certainty. That 0.4, that last digit, is the one that's been estimated. It's been rounded by the machine because the machine will not go any further than to the tenths place. I'm assuming it's a digital scale. And so that last one is estimated, but it is included as a significant figure. Now please don't mistake significant figures with what the word says, significant. It means significant not based on whether the digit in the number matters. It's based on whether that digit has significance according to how it's been measured. And that's where you see in this bottom definition, it's in a measurement. So it has to do with whether the number is significant based on the measurement. Ultimately, we're saying how accurate are the measurements? How precise did the measurements go? And so here we see an example. We look at a number and there's all these numbers. Ultimately, there's only one type of digit we are concerned with, and those are the zeros. So when we look at significant figures, it's the zeros are the ones that are in question. And in this section, I'm going to ask you to refer back a lot to your Chapter 2 Tables worksheet. It has a very detailed explanation for what figures are significant. So if we look here and you look here, they're showing the first 3 zeros not being significant, and they're showing all the rest of them being significant. And so there's reasons and rules for each of that. You should be able to look at this at the end of this chapter and easily identify that there are 7 significant digits in this number, or significant figures in this number. If you feel like Rodney right now, that's okay. It might take a little time, but I need your patience and I need your honest effort to get this, because when we start looking at these numbers from this chapter on, every number you make in a calculation, and almost every chapter will have math calculations, will have to be in significant figures, otherwise you're losing points. And so even if you feel that way, hang in there. We'll get you through this. Everyone will get it eventually. So let's just talk about the basic rules for significant figures. Here's that same picture I showed on the last slide. Has a whole bunch of digits in question here, and we need to take a look at all of those. Again, feel free to refer to your tables worksheet. So the first rule, any non-zero digit is significant. Zeros are the only ones that we're worried about. So the 4, and the 5, they're non-zero digits. They're absolutely considered significant. You never have to worry about significant figures being a digit. It's the zeros that we need to make sure we know. All zeros between non-zero digits are significant. So there you see those 2 zeros between the 2 4s. They are considered significant because they're sandwiched in between significant digits. And hopefully that makes sense, that you're not going to have a significant digit and then one that's not and then the one that is. They will all be in a row. It's just where do they start and where do they end. Then we see zeros to the right of a non-zero digit but to the left of an understood decimal point are not significant unless the decimal point is included. That should be a D there, included. So when we look at this this number here, what we're talking about are those 2 zeros in front of the 4. They are only used to show how large the number is. They're only used to locate the decimal point. And we'll talk about this in a little bit more detail later. I'm going to throw out a basic idea at the end of this, but those zeros are not significant because the number hasn't even started picking up measurement until it gets to that first 4. And so again, that first 4 is the first significant figure. Those 2 zeros in front of it are not considered significant figures. Now also, if you notice, in the very front of this number, that first 0 doesn't have to be there. If you're going to write something as 0.5, a lot of you don't write 0.5. Technically you should, but that 0 is what we call cosmetic. It's just there to make the number look a little better so we recognize where the decimal's at. This fourth rule is probably the most important rule looking at zeros. Placeholders are not significant. When we talk about placeholders, they're either placeholders saying how big a number is or how small it is, but a placeholder is not a significant figure within the measurement. They are significant zeros because they're saying how big the number is, but they're not considered significant figures. So we have two little subcategories here: zeros to the right of a decimal point, but to the left of the first non-zero are placeholders. That's what I was talking about before with those 2 zeros. And then we also see zeros to the right of a decimal point and to the right of the first non-zero digit are significant. Now, again, come with questions. I want to explain this in class a little bit. I'm not going to try to do it all over this video lecture. But those zeros on the end are significant because why are they there? The reason they're there is because however this number was measured, it was measured all the way out to that last decimal point. Now that very last 0 is rounded, that's the uncertain one, but it is significant because it's saying how accurately this number was measured, and that is the focus of significant figures, is to understand the preciseness of the measurement. That's what it's all about here. So, maybe you still feel like Rodney right now. I understand that. We're going to move forward with just a couple more ideas and rules here, but we'll try to get you through this as painfully as it might be right now. Please hang in there and stick with this. Let's look at rounding rules now. Now this is very similar to what you've always seen, and again, this is on the worksheet. The key thing are 4 and 5, or it should be 3, 4, and 5. Anything that's above 5, we always round up, and so we see this example on the number 1. We're rounding all these to 3 significant figures, and we see it's 42.68. So to get 3, we need to round that 6 off. Because the 8 after it's bigger, we round it up. Pretty simple. Same thing, less than 5 though. If we're going to round the 3, we look at the 2 behind it. It's less than 5, so we leave it the same. We either leave it the same or round it up. In that case, we leave it the same. Now the issue that we have here is, what if that number is a 5? What you've always followed, which is a basic rule, is that if it's 5 or more, you round up. But the problem is when it's 5, it's exactly in the middle. It's not a little bit in the middle, it is exactly in the middle. And if you don't know anything past the 5, that kind of throws it. And so the first one we're going to say, well, if there's a 5 there, but there's more numbers after the 5, essentially that number is 5 and a little bit more. So if we look at this number, we want to round it to the third significant figure, which would be the 8. So I'm on the third one here. We look at the 5. The 5 doesn't automatically round it up, but because there's another number after the 5, it means 5 and a little bit more, so it's a little past that halfway mark. We do round that one up. Now if we look at number 4, this time there's a 5 there, but there's nothing after the 5. So we're at 4.635. We want to round the 3. Again, in the past we always said we always round up if it's 5 or more, but again, 5 is right in the middle. It's not fair to do that. Now in this case, I'm not sure who or why this was the rule, but I like to call this the even-steven rule. It might sound kind of silly, but that's what we're going to go with. And what we're saying is the number we're rounding, if it's a 5 after it, we need to have a way to decide whether we leave it or round it up, since 5's right in the middle. If that number is odd, you make it even. If it's even, you leave it alone. And so again, that's why I call it the even-Steven rule. The 3 is not an even number, so we round it up to a 4, which is even. If we look on the bottom one here, it's followed by a 5, but the number we're looking to round is the 6. It's even. And so we leave it alone to keep it as even, or even-Steven. Haha, I know it's really corny, but hey, if it works, that's what we're going to go with. So we've got one more slide here. And this is pretty challenging area here, and this is the part where I think it's going to get a little bit crazy, but just do your best to follow along here. We've got addition and subtraction, we've got multiplication and division. If we want to add or subtract numbers, our answer has to be in the correct number of significant figures. This is a challenge. And so our rule here is the result is rounded so that the last digit, the final digit, which is the furthest to the right, is in the same place as the leftmost uncertain digit. Now that's maybe a lot of words there to understand this, so I'm going to pop up a picture here. If we look at these 3 numbers that are being added, we're going to round our number to the last place we can, but the place where all 3 of these numbers has a digit at. If we look at each of these 3 numbers, they all have a number. The last digit they all have that they have in common is in the tens place, the 2 and the 2 and the 4. And so we see in red, that's the last digit retained. And so the other numbers behind it are going to be dropped. However, that 8 is still going to be rounded based on what's behind it. So that 9 being right behind it rounds that 8 up to a 9, and there we see our number being 3,760.9 because the 8 was rounded up, and we want to end it at the tens place. This is the key thing here, especially if you're all like I am, which I am very visual, I've got to see it, is to line up your numbers that you're adding and subtracting so that all the decimals in each number lines up. If you do that, you're going to be in good shape here. It may seem kind of simple, but this is the easiest one to forget. Now, multiplication and division, just like with scientific notation, is simpler. The result is rounded so that it has the same number of significant figures as the number that had the least amount of them. So again, an example is what we need to look at here. We're going to round off our answer to the least number of significant figures of the numbers used. So here's the first, here's our example. We've got 3 numbers being multiplied, 34.6, 12.1, and 1.2. If you look at each of those numbers individually, 34.6 has 3 significant figures, 12.1 has 3 significant figures, and 1.2 though only has 2 significant figures. So when I look at this number, I've got to round my answer to the least amount of all those 3, and the least amount is 2 significant figures. So I multiply them all, I get 502.392, and I realized I've got to round this only to 2 significant figures. So I start with the first one I come to that's significant, which is the 5, and I go to the next number after that. That zero's between 2 numbers that are significant, so it counts as a significant figure, but that's where I need to round this. Now, this example is really not a good one because we'd think, oh, it must round to 50, but the number is 502, so the number would really need to round to a number that's the same size. It'd need to round to 500, but we also need to show that that 0 is significant. So in this case, we're going to round this we're going to adjust this number into scientific notation as 5.0 times 10 to the second power. That 0 in that number is significant because it's there after a significant figure and still to the right of the decimal point. Main reason that I can explain this maybe better than the rule is that why else would I put that 0 there if it wasn't significant? And we said I needed 2 significant figures here, and so that does count as a significant figure. We're going to look at this problem in class. I'm going to show you how to round it and write it as significant figures without doing scientific notation, and we'll look at lots of examples. Please go back through this a time or two, especially with the math, or maybe even more importantly, just the basis for determining significant figures. It's not the easiest. Hopefully what we've done in class will echo this and mimic it so that you can understand it. I'm going to present it to you as many times as I can, and we're going to do this all year. So we got to get it now as fast as we can, as soon as we can, so that we have it moving forward. That's it for video lecture 2.3.